Good morning, grade 10s. How are you guys doing today? Welcome to this physics lesson where we are looking at specific heat capacity. In the previous lesson, we looked at heat capacity. So you find that there are subtle differences, right? In fact, they are very big, but we will just say there are subtle differences that are there between heat capacity and specific heat capacity. So by the end of this lesson, we must be able to define specific heat capacity, recall and use the equation for specific heat capacity. Then we might not get to the point where we describe an experiment, but I will refer you to some work which you should look at, where you use an experiment to measure the specific heat capacity of a substance. Okay, so before we proceed, you can just pause the video, look over the objectives, then you can also quickly just look at your notes on heat capacity. This is specific heat capacity. The previous lesson was on heat capacity. Okay, specific heat capacity, the other one was just heat capacity. So you can just pause the video now and just have a look at the objectives and also at the PDF on heat capacity. Okay, so now today we are saying we are looking at specific heat capacity, and the main thing that I would want to do would be to differentiate the difference, to say what is the difference between specific heat capacity and heat capacity. Because you recall that in the previous lesson we looked at how heat capacity is also amount of heat required to raise the temperature of a substance, the amount of heat required to raise the temperature of a substance. But in that one, you will find that now we are dealing with specific quantities, a specific mass. So you will find that when we say heat capacity, specific heat capacity, amount of heat required to raise the temperature of 1 kg, 1 kilogram of a substance by 1 Kelvin. Okay? That is the definition, or what is meant by specific heat capacity. And the formula, if you take note of the formula here, that if you recall your formula for heat capacity, you know that the formula for heat capacity was Q over delta T. The Q representing the what? The energy, whereas delta T, that little triangle, and the T were representing a change in temperature. Now on this one, you find that we have now included to that equation for heat capacity, we have now included mass. We have now included mass. So specific heat capacity is equal to Q, which is heat energy, divided by mass, multiplied by delta T, which is temperature rise. The units for specific heat capacity are joules. Remember the units for energy, joules per kg, because your mass is in kg, per Kelvin, right? That is the unit for specific heat capacity. Okay, so right now I need you guys just to go over, just to look at the formula. The formulas are very important, yes? Let us always recall that the formulas are very important. I've seen you in our chemistry lessons how you are just trying to take numbers and then just divide or multiply numbers whichever way you want. Please understand that with these concepts, it's not really a case of saying, do you know what 5 times 3 is? It's a case of you knowing where to place the 5, where to place the 3, if knowing that this is my energy, this is my mass, this is the temperature change. And when you know where to place those different quantities, then you can do your calculations, and then it becomes very simple. Okay? I am just bringing some of the problems that I've seen when we've been doing stoichiometric calculations, that you guys have just been taking numbers and you have been feeding them and putting them to places where they don't belong. Right? Then you just say, is my answer correct? Is my answer correct? The first thing you have to do is to understand your formula. Understand what the units or the variables represent, as in this case, specific heat capacity, small letter c. Remember, heat capacity is a capital letter C. Specific heat capacity, small letter c. Equals to Q still represents heat energy, M represents mass, delta T, change in temperature. Units, joules per kg per Kelvin. Okay? Joules per kg per Kelvin. So please just pause the video again and go over this formula and make sure you understand it. Okay, let's go over this simple calculation. I think we did it in the previous lesson, but I'm going to explain it again here. Where we have the power of an electric pot as 5.6 kilowatts. Yes, that's kW, that's kilowatts, 5,600 watts. And remember that power is effectively a rate at which work is done. And work is done, and the formula or the unit for work done is joules, because that's energy, the unit, right? So work is work done per second. Power is work done per second. That's the rate at which work is done. So that's your energy per second. So this one becomes 5,600 kilowatts, which is the same as 5,600 joules per second. Now, you can read the question. It says, if it takes 4 minutes to heat 25 kgs of water from 20 degrees Celsius to 60 degrees Celsius, calculate the specific heat capacity of the electric pot. So when you are given a word question like this, okay, the numbers, you can see the numbers. You can multiply, you can divide. But what you need to know is to say, okay, this 5.6 kilowatts, how exactly am I going to use it in this equation where I say specific heat capacity is equals to energy over mass multiplied by temperature rise. So you then go to your 20 degrees, change from 20 degrees to 60 degrees. From there you get to see, okay, there's a change in temperature here. That's most likely where my temperature rise is. You get to see there's 25 kgs of water there. That's most likely what my mass is for this particular. You're now substituting M. I substitute M with 25 kgs. I substitute temperature rise with 20 degrees to 60 degrees. Where do I get my Q? My Q, I have to get it from the power and the time, right? Because if you say power is joules per second, and you are looking for energy, and energy is just joules, it means you have to remove these seconds, okay? I hope you can then pause this video and replay it. I'm just going to speak through it, all of it, but you can pause the video and replay it, okay? So I'm saying that power, the unit for power is the watt, and that watt is equivalent to joules per second. So if you want to put it back to energy, right, you want to remove it now, it's joules per second, and you want to put it back to joules, it means you have to multiply by seconds. And here you have been given 4 minutes, right? You have been given 4 minutes here. So you simply convert your 4 minutes to 240 seconds. Where did we get the 240 seconds from? You know that 4 minutes, each minute has 60 seconds in it, so you multiply by 4. And that's how you end up getting to this point where you want to get. Here, this heat energy, you're just looking for Q. That's all you're doing on this one, right? So you say 5,600 joules multiplied by 240, 5,600 joules per second multiplied by 240 seconds. That's equals to 1,344,000 joules. That's 1,344,000 joules. Okay? I know you're grade 10s. I know this is now senior secondary. But some of you right now will be reading that as 133,440. No, read it properly. That's 1,344,000 joules. Your delta T, your temperature change. Now, you have been given temperature in degrees Celsius, but we know that for these calculations, we do them using, what do we call? Kelvins. So you go back to your Kelvin scale, and you know that 20 degrees Celsius on the Kelvin scale is 293 kelvins. Remember, you will say final temperature minus initial temperature. Because here, you need to have final temperature minus initial temperature for you to know what the temperature change was. So 60 degrees Celsius is equivalent to 333 kelvins. less or minus 293 kelvins, which gives you a temperature change of 40 kelvins. So now you can substitute values for this one. You are still looking for your specific heat capacity. You can substitute Q with 1,344,000 joules. You can substitute mass with 25 kgs. Change in temperature, you substitute it with 40 kelvins. And when all is said and done, and you do that calculation and you do it properly, you get your answer as 1,344 joules. 1,344 joules per kilogram per Kelvin. Per kilogram per Kelvin, because you have divided by a kilogram, you have divided by a Kelvin. Understand, please, why you say per kilogram per Kelvin. That kg -1 means per kilogram. That means per Kelvin. Right, so what I also put in here was a relationship between heat capacity and specific heat capacity. To say, using this one, if you know the formula for heat capacity and you know the formula for specific heat capacity, you find that you can actually have a relationship between the two. You'll find that when you end up deriving, I'm checking the time. Okay, when we say the capital letter C, remember, that's heat capacity, where you only have energy over temperature change. Okay? That's heat capacity. This second one, that's specific heat capacity. The big letter C, capital letter C, is heat capacity. The small letter c, that's specific heat capacity. So these two equations, you will find that heat capacity is equal to energy divided by temperature change, where you can then say energy is equal to heat capacity multiplied by temperature change. It's just, that's what I keep on saying, make it subject of the formula. It's just making the Q the subject of the formula. So we also know here that specific heat capacity is energy divided by mass multiplied by temperature change. So when you then substitute, you can then substitute and say, if this Q, if Q is equal to C delta T, it means that you can actually place it here. That's what they've done. What they've done is they've said, if this Q, I can replace it with C delta T, because you see on this part of this first equation that Q is equals to C delta T. Capital letter C, that's heat capacity multiplied by temperature change. So this is the same. So specific heat capacity can also be written as C delta T divided by M delta T, which means that specific heat capacity, the formula for specific heat capacity can also be given as C is equals to heat capacity divided by mass. Or you can say heat capacity is equals to mass multiplied by specific heat capacity, right? So it says here, not if you are given heat capacity and mass of a substance, specific heat capacity can be calculated, right? So if you are given the heat capacity and the mass of a substance, then the specific heat capacity of that particular substance can be calculated. It can be calculated. And we also put in, like, there's a proportionality. You know, obviously, that the longer you heat something, the more the heat in that substance increases. Okay? The more the heat in that substance increases. So, thank you guys for watching and listening. What we'll do is we'll discuss this material again in this WhatsApp lesson that we're going to have immediately after you watch this video, so that you can ask any questions if you have any. So thank you very much, guys, for paying attention and giving me a bit of your time. This is Marshall AC Candiado. Goodbye.